Today we are going to look at one of Mother Nature's most powerful forces, tornadoes. These amazing windstorms harness more raw power and destruction potential than any other phenomenon on Earth. With winds reaching upwards of 300 miles per hour and the potential of a base of over a mile wide, these tremendous storms can wreak havoc on property and people alike. As we look deeper into the causes and effects of tornadoes, we will have the opportunity to learn what conditions create a tornado, how they are classified, where they occur most often, and finally see some examples for ourselves. Tornadoes are formed from supercell thunderstorms. In order for a tornado to be formed from these cells, you need three very different types of air to come together in a particular way. First, near the ground, there's a layer of warm, humid air and strong south winds. In the upper atmosphere, you'll find cooler air and a strong west or southwest winds. The air near the surface is much less dense than the cold, dry air aloft. This condition is called instability. It means that if the warm, moist air can be given an initial push to move upwards, the air will continue on rising, sending moisture and energy to form a tornado's parent thunderstorm. The second ingredient is a change in wind speed and direction, called wind shear. This is linked to an eventual development of rotation from which the tornado may form. The last thing you need is a layer of hot, dry air between the upper and lower layers. This middle layer acts as a cap and allows the warm air underneath to get even warmer and to make the atmosphere even less stable. The geography of the central U.S. is uniquely suited to bring together all the ingredients for tornado formation. Averaging more than 500 tornadoes annually, this area is called Tornado Alley. The states at the highest risk of getting a tornado include Arkansas, Iowa, Kansas, Louisiana, Minnesota, Nebraska, North Dakota, Ohio, Oklahoma, South Dakota, and Texas. Peak months of tornado activity in the U.S. are April, May, and June. However, tornadoes have occurred in every month and at all times of the day or night. A typical time of occurrence, however, is an unseasonably warm and humid spring day between 3 p.m. and 9 p.m. When it comes to tornadoes, being prepared is more critical than for any other natural event. That's because tornadoes can strike suddenly, sometimes with no warning. It's important to learn the natural signs of a tornado and discuss what to do in the event of emergencies. These signs include an unusual greenish or black color in the sky, hail or heavy rain followed by either dead calm or a fast, intense wind shift, a visible funnel cloud that has not yet touched the ground, a loud, continuous rumble that does not fade after a few seconds, as does thunder. And lastly, tornadoes have been described as sounding like a jet, freight train, or even a waterfall.
Rob Nelson here with your weekly Untamed Science video. Now, it's tornado season. Turns out Haley and I actually experienced an F0 tornado by accident. It was kind of scary. Mostly for Haley, but I said a lot of cuss words too.
Get out of here! Get out! Get out! Get out of here! You getting this? I'm getting it.
That was it.
All right.
That was it.
We ran through it.
I want to talk about how you classify tornadoes. Why is it that you would even want to know about the scale of a tornado?
Wall clouds for me. We're gonna get a tornado.
It's not all that accurate to say it was a big tornado, or it looked like this, or it looked like this. So, back in the 1970s, this guy named Fujita came out with a scale.
Man, I have this great scale
Called the Fujita scale. And it's been adopted worldwide, so that's what everybody uses nowadays. That scale classifies tornadoes from an F0 all the way up to an F5. The Fujita scale is a determinant of what damage is actually caused, and that correlates to the wind speed. But wind speed isn't actually what determines the Fujita scale, it's damage. So let's go through from an F0 to an F5 and see what damage is actually occurring at each individual type of tornado along that scale. First, the F0. Some damage to chimneys, it breaks off branches of trees, pushes over shallow-rooted trees. On an F1 tornado, it peels the surface off of roofs, mobile homes are pushed off their foundations and overturned, moving automobiles are pushed off the roads. Now an F2 tornado is a significant tornado. Roofs are torn off of framed houses, mobile homes are demolished, box cars can be pushed over, large trees are snapped or uprooted. Now an F3 tornado is a severe tornado. The roof and some walls are torn off of well-constructed houses, trains are overturned, and most trees in the forest are uprooted. Now an F4 tornado is a devastating tornado. Well-constructed houses are absolutely leveled. Cars are thrown and large missiles are generated. Now an F5 is an incredible tornado. They're also not all that common. Really strong framed houses are lifted off of their foundation carried considerable distances, and then they disintegrate. Automobile-sized missiles fly through the air in excess of 100 meters. Trees are debarked. Now, the tornado in Joplin, Missouri was an F5. And 160 people died, which is a lot of people. Mr. Fujita actually put in one more onto the scale, an F6. Now, an F6 is actually called an inconceivable tornado because of the wind speeds are so high that it'll probably never happen. I can't even think of the damage that would happen from an F6 tornado. But we've never had one, so we don't know. So remember, tornadoes are not classified by the wind speed. Tornadoes are actually classified by the damage that occurs.
Today we have many movies about tornadoes that attempt to show the awe-inspiring power that tornadoes produce, the chaos it can cause. Seemingly everyone is caught up in the behavior of these natural disasters. Even still, little is known about them for sure. People put their lives at risk daily to advance the understanding of tornadoes for scientific purposes and for the adrenaline rush provided by the danger of being close to these megastorms. The producers of the movie Twister show us some very interesting things you might find in a tornado. Take a look and you can see what I mean.
Bill, we're in the core.
Okay, we got sisters.
Yes? Julia, I can't talk to you right now.
We're right under the flanking line.
I realize that.
We can't attack this thing from the south. We're gonna get rolled.
Watch.
Julia, I know you're upset. You just gotta breathe. We both just gotta breathe.
Cow.
I gotta go, Julia. We got cows.
Another cow.
Actually, I think that was the same one.
Hey, it's Cantori, man. Right in the town of Edmond, Oklahoma.
Tornado on the ground.
Stop right here. The debris too big.
Maybe 50 yards right now. There's debris over my head.
Oh my God! It's a large
Oh,
wedge.
it's huge. Look at that. See the horizontal vortices?
Yes. This is
Oh,
a
my
violent
goodness.
tornado, guys. Hold on. This is bad damage here. When a tornado is not moving side to side, it's coming right at you. This one is coming right at us.
Watch the door! We'll get ripped off.
Dude, we gotta go. Reed! Drive!
As you can tell, storm chasing is a very dangerous lifestyle. Thanks to the efforts of these men and women, hopefully one day we'll be much better prepared for tornadoes. Hopefully we can save many people and their property from damage caused by tornadoes. For the time being, I'm thankful that you've been able to watch this video and hopefully learn a little bit more about tornadoes. They are amazing storms with unspeakable power. If viewed at safe distances, they are some of the most interesting things Mother Nature has to offer. If viewed up close, however, watch out. They can bring unimaginable damage to those things around them.